Okay, acceleration is kind of our next topic here, and can be simply defined as changes in velocity. Our overview is we're going to see how can we calculate changes in velocity. We've got a few new words: acceleration, initial, which is not necessarily a science word, but is helpful here, and deceleration. So we'll hit those here in a moment. Acceleration describes how an object's velocity changes over time. Previously, we're talking about how something's position changes over time. This is how something's velocity changes over time. And remember what velocity is. Velocity is speed in a given direction. So any kind of change in velocity is acceleration. So with our velocity, it can slow down, it can speed up, but also velocity changes if we change direction. And if we change direction, then that's accelerating as well. All right. So let me go back to that. It says we can move without accelerating. That will just be constant motion. So if you're going 60 miles an hour in a straight line, that is not acceleration. So it's possible to move and not accelerate. And we went over that previously, just as constant motion. We have a formula for average acceleration. It's represented with this lowercase a. Delta v is a change in velocity. Delta t is a change in time. So acceleration mathematically is your ending velocity minus your beginning velocity, your ending time minus your beginning time, effectively how much your speed changes, how much your time changes. Right. So change in velocity over time. This is on your formula reference sheet. We don't have to memorize them. They're there for us. If you have acceleration can be positive, negative, or zero. So if you have a positive acceleration, that means the velocity is increasing. So you're speeding up. If you have a negative acceleration, that means that your velocity is decreasing. So you're slowing down or decelerating. And if you have zero acceleration, that means your velocity is constant. So one little source of confusion, you can have zero acceleration again and still be moving. That doesn't mean you're stopped. So zero acceleration just means you're not changing whatever velocity you have. It's possible to have zero acceleration and not be moving. You would be stopped at that point and continuing to not move. But zero acceleration does not mean that you're not moving. The units for acceleration are meters per second because it's basically velocity divided by time. This ends up coming out to being written shorthand as meters per second squared, as opposed to just meters per second. So meters per second is speed or velocity. Meters per second squared is acceleration. So how can we speed up in a car? We can accelerate in a car different ways. We can speed up with the gas pedal. We can slow down with the brakes. We can change directions with the steering wheel. So any of those times when you're in a car, if you feel motion, usually there's an acceleration. If you're going 60 miles an hour down the road constantly, oftentimes we don't really feel the motion unless there's bumps, which technically then those are accelerations up and down. But if you were just perfectly going at an even speed, you don't really feel the motion that much in the car. You feel it when you stop, you feel it when you speed up, you feel it when you turn. One of the things we have to do in this unit is to do a lot of math or be able to show that we can do math. The formulas on the right-hand side are given to us in our formula sheet. We just have to know how to use them and recognize how to use each one, and sometimes how to rearrange some of these. The formulas use symbols. Those are all over here on the left-hand side as well. Again, you don't have to memorize these, but get A for acceleration and so forth. You got several V's. You got an average velocity, I for initial velocity. Again, that means your beginning velocity. Where did you start from? Your F for your final velocity, and a delta V would be a change in velocity, which will be the difference between your final and the initial. All right, so we got a lot of symbols, a lot of formulas. Don't have to memorize them, just have to be able to use them. So for example, if you read a question that says, how fast was it going? That's your initial velocity, VI. If you see a question that said, how fast will it go? That's going to be your ending velocity, your final velocity. If the scenario says an object starts at rest, well, that's what it started with, so that's this VI. And if it's at rest, it's not moving, so it has no speed. If the object slows down, then we know that the acceleration ends up being a negative value because its final velocity is smaller than its initial. And an object comes to a stop, that means its final velocity is going to be zero. And during that time frame when it was stopping, it would have been slowing down. So its acceleration value should be negative as well. So just kind of some common things to keep in mind, and also ways to interpret some questions. Now, when we do have questions, we got a series of ways that we can kind of go about thinking of them. The first one is make sure you just make a list of everything that's given to you in the problem, and then pinpointing what is it that the question is asking for. What is our unknown? Based upon that, you should be able to figure out which equation you need to use, or at least narrow it down. Plug your numbers in, solve it, and then you include our units on the final answer here. So a few examples. Example number one, if we have a car accelerating from a traffic light, its velocity increases from 0 to 20 in 5 seconds. What is this acceleration? So again, step one is let's identify what is it that we know, what do we not know. So we know the initial velocity was 0, we know the final velocity was 20, we know the time was 5. Those are all given to us in the problem. And then what we're missing is the acceleration right here. And again, if you need to pause this so that you can write things down, please do. We'll look over here on the right-hand side to figure out which formula we need. We can eliminate a number of them. For example, there's no distance involved in this problem. So anytime we see a d, we just can't use that formula because we don't have a distance. So we can skip this one. We can skip the fourth one. We can skip the sixth one. The only ones that are kind of left is the second one and the first one. And the second one is the one we're going to probably best use because it's delta v over t, changes in velocity over time. It gave us the two velocities. It went from 0 to 20. So the bigger number goes first because it's speeding up. And we divide that by 5. So again, this 4 meters per second squared is going to be our acceleration. If you put your numbers in backwards, you can make sure that you kind of common sense it. Because if you went 0 minus 20, you would get -4. And if it's -4, it should be slowing down. If you go back and read this, it's going from 0 to 20, which is speeding up. So if it's going from 0 to 20, we need to get a positive answer, not a negative answer. So this will be the final solution for example problem number 1. Example problem number 2, again, we've got the formulas to look at. The same car previously, if it travels for 10 seconds and it's got a constant velocity of 20 meters per second, what is the acceleration over that 10-second period? So again, what do we know? So we got a time of 10 seconds. It's a constant velocity, so its beginning and ending velocity are the same. And I'm trying to ask for acceleration. So again, I know my two velocities. I know the time. I don't know acceleration. That's going to use this formula again. Again, it doesn't have a d, so we can't use any of the ones that have a d in it. It does have everything to use this fifth one, but the second one's a little bit simpler to use than that one. Because we're trying to find out a, so this is going to be the easier one to use. If we're trying to find the final velocity, the fifth one would be the easier one to use. So we got our formula that we're going to choose from. We're going to plug everything in properly. 20 minus 20, those are our two velocities. Divide that by the change in time, which is 10. And our acceleration is 0, which makes sense because it stayed 20 meters per second the entire time. It was neither speeding up nor slowing down. It was in constant speed. So its answer is going to be 0 for that one. Problem 3, that same car that was going 20 decelerates at a ½ meter per second squared. How long will it take for the car to come to a complete stop? Again, it was going 20 meters per second. It came to a stop, so it was going 0. It decelerated. Good. So that's slowing down. If it's slowing down, it's negative 0.5 meters per second. And we're trying to solve for delta t, or a change in time. Again, I know two velocities. I know an acceleration. And I'm trying to find the time it takes. Again, I'm going to use this formula, but the problem is that delta t is on the bottom of the formula, and I have to end up rearranging that formula to be able to use it. So one of the things we can do pretty easily in terms of rearranging a formula is if the thing I'm solving for is at the bottom of this fraction, one of the things I can do is end up just swapping these out. Mathematically, what happens is I would have to multiply both sides. If I multiply both sides by delta t, then those are going to cancel out. And then I would have to divide both sides by a to get this to cancel out. And the shortcut is they just end up swapping places. All right. So that's one of the ways that we're kind of able to quickly rearrange this formula. That you'll notice the a and the delta t that are in our given formula simply swap places down here. I substitute my numbers. It ended at 0. It was going 20 to begin with. And an acceleration down here that was 0.5. This actually should be a negative 0.5, the way that we had it. So you'd have negative 20 over negative 0.5, and it gives us a time that would end up being 40 seconds. So make sure that you have that on there. Let me get a little annotation up here so I can have it. It's a little typo that was missing. So that should be a negative because it was decelerated. Right. All right, one last one. Get everything cleared out up here. All right, car accelerates from rest to a final speed of 40 meters per second and 100 meters. What's the car's acceleration? Same routine. Let's write down all the things that we know. So it accelerates from rest. So we know how fast it was going to begin with. We know how fast it was going at the end. We know how the distance that it takes. We don't know the acceleration. So we know these things. We know VI, VF, D, and we don't know A. So if we come over here, we can't use any formula that has time in it because we don't know the time. That eliminates the first one, the second one, the third one, the fourth one, and the fifth one. The only formula that doesn't involve time is the one at the bottom. So we can't use any of these first 5 because we don't have a time, or we're not even trying to solve for time. Right. So I use that last formula, which is final velocity squared equals initial velocity squared plus 2AD. We have to rearrange it because we're trying to get A by itself. So this is where some of your algebra is going to have to come in to be able to get things by themselves. Hopefully you see from the first formula, the first formula down here to the second, we end up subtracting out the VI squared from both sides. So that gets the 2AD by itself. If we subtract the VI squared out on both sides, we end up getting this left on one side. We need to get A by itself. So mathematically, we need to divide out the 2, and we need to divide out the D. So if we divide this side by 2D, we're left with A. And if we're divide this side by 2D, our formula then changes to this. So this is the given formula. If we rearrange it, we can make it look like this. Then we just need to plug things in. And when we plug things in, we're going to plug in a 40 for the final velocity, a 0 for the initial velocity, divide that by 2 times the distance, put this into our calculator, and we're going to get an answer of about 8 meters per second squared. Right. So in summary, acceleration is just a change in velocity. There's a number of formulas that we can use to calculate velocity or distance or time or acceleration in any kind of given scenario. We're given those formulas. We don't have to memorize them. We just need to know how to use them. So we need to be able to practice with them so that we can end up using them. Thank you.